All right, so if you're an applied social science researcher, you totally know the drill. You've poured all this time and energy into making a fantastic survey. But before you can actually test your big ideas, you've got to get through that super crucial and, let's be honest, sometimes frustrating step of validating your measurement model. And that, of course, is where confirmatory factor analysis, or CFA, comes in. Now, if you've ever felt just a little bit unsure about the absolute best way to tackle it, believe me, you are in very good company.
And we're not talking about some obscure statistical technique here. The source material for this explainer points out something pretty staggering. About half, that's right, half, of all researchers who collect their own primary data depend on CFA. It's a cornerstone of modern quantitative research, which makes it all the more critical that we get it right.
And that, leads us to the big question. Are we actually doing it right? Many of us learned CFA from textbooks that, while they were foundational, now have some advice that's a little bit, outdated. And this isn't just some academic squabble. It can lead to what the source calls suboptimal decision-making. Basically, choices that could be weakening the very foundation of our research.
This slide just perfectly captures the heart of the problem. Our textbooks and our software's default settings, they're often built for this ideal world of continuous data, using a method called maximum likelihood. But our reality as researchers is almost always ordinal data from surveys. Those classic 5-point strongly disagree to strongly agree scales. That kind of data is different, and as we're about to see, it really demands a different kind of analysis.
So this mismatch leads to a really common frustration, the software struggle. I'm sure you felt this. The gold standard tools like M+, they can be crazy expensive. The ones that are widely used, like AMOS, often just don't have the specific features we need for this kind of ordinal data. And yeah, there are these powerful free tools like lavaan and R, but wow, that learning curve can be steep. Then you've got user-friendly software like JASP, which is a huge step forward, but as the source points out, it has some really important limitations we have to be aware of. Okay, so with all those challenges on the table, what do we do? How do we move forward? Well, thankfully, the source gives us a really clear evidence-based solution. It's a 6-step framework that basically acts as a modern roadmap to doing a CFA that's methodologically solid. And here they are, the 6 steps, pulled right from the source's appendix. This whole framework is designed to walk you through the entire process, from picking your model and prepping your data, all the way through estimation, fitting, comparing models, and even doing a final power analysis. You can think of these as the essential building blocks for a really robust and defensible CFA, one you can actually feel confident about. So let's dig into a few of the critical upgrades. First up, the estimation process. Instead of just going with the default, which is usually maximum likelihood, best practice for ordinal data, our Likert scales, is to use an estimator like diagonally weighted least squares, or DWLS. It's simply the right tool for the job. It was built from the ground up to handle the unique nature of your survey data. The second big upgrade is all about how we measure reliability. For decades, Cronbach's alpha was the go-to metric, but now we know it has some pretty serious limitations. The source makes a strong recommendation here. It's time to move to a more accurate, more modern measure called McDonald's Omega. It's basically a straight swap for a much better metric. And this leads us to the third major shift, and it's a big one. It's time to let go of those rigid rules of thumb for model fit that we all had drilled into our heads. Like a CFI has to be above 0.95. The current best practice is to use something called dynamic fit indices. This uses simulation to create cutoff values tailored specifically for your model. It's a huge shift from a one-size-fits-all approach to a much more precise, customized evaluation. Okay, so this all sounds great in theory, right? But what does it actually look like when the rubber meets the road? Well, let's take a look at the tutorial example from the source, which uses a really well-known instrument, the WHOQOL-BREF scale. This is just the perfect real-world case study. It's a quality of life scale, it's got 24 items, it uses a 5-point Likert scale, and it has this really well-established 4-factor structure. I mean, this is the classic CFA problem that thousands of researchers face every single year. Now check this out. The tutorial shows how you can go beyond just a simple confirmation. So instead of only testing the one established model, it actually compares 3 different theoretically plausible alternatives: the standard 4-factor model, a bifactor model, and a second-order model. This really highlights a key idea. Good CFA isn't just about checking a box. It's about thoughtful model comparison. And here is maybe the most critical lesson from the whole tutorial.
Even though one of the other models had slightly better-looking statistics, the authors argue for sticking with the original four-factor model. Why? Because it's backed by a ton of theory and decades of research. It's such a powerful reminder that the model with the prettiest numbers isn't always the best or most meaningful choice for your research.
So, the big question is, how can you actually do all this without getting lost in a sea of complex programming? Well, the source suggests a really powerful hybrid workflow, one that combines the strengths of two awesome free software packages, JASP and lavaan.
This hybrid approach really gives you the best of both worlds. On one hand, you've got JASP with its incredibly user-friendly point-and-click interface. It's amazing for doing your initial analyses and seeing results pop up in real time. Then, on the other hand, you have lavaan in R, which unlocks the full power of code for more advanced stuff, and this is so important, ensures your work is completely reproducible. They really are a perfect team. But here's the crucial detail you have to know. At the time the source was published, JASP didn't have something called Scaled Global Fit Indices, and those are absolutely essential for properly evaluating models that you estimate with DWLs. This limitation is exactly why you need to bring in lavaan to finish the job and make sure your analysis is truly robust and defensible.
So let's wrap this all up and focus on what this really means for our work. Adopting these best practices isn't just about being technically correct. It's about building better science. Science that's more transparent, more reproducible, and ultimately a whole lot more trustworthy.
I just love this quote from the source. It perfectly captures the right mindset for this kind of work. Validation isn't a one-and-done task you just check off a list. Nope. It's an ongoing process of gathering evidence, especially when we start applying our measures to new situations or new groups of people.
So, what are the big, actionable things you can take away from all this? I'd say there are 4. First, match your method to your data. Use DWLS for your ordinal scales. Second, update your reliability metrics. Choose McDonald's Omega. Third, rethink model fit. Start exploring customized approaches like dynamic fit indices. And finally, number 4, supercharge your workflow by combining the ease of JASP with the power of lavaan.
And that really just leaves us with one final thought. The tools and the guidelines, they're all here, and they are more accessible than they have ever been. So the only question left is, how are you going to use these best practices to strengthen your next research project?